So, why study chemistry? Chemistry describes how substances interact with one another. It is the fundamental science behind biology, pharmacology, and all of the other life sciences. Over the duration of this course, we're going to be looking at how this will then impact the medicinal sciences, and we're going to be looking at some elements of medicinal chemistry. Indeed, the importance of chemistry itself cannot be understated, so it is a fundamental science into which medicinal chemistry is rolled. So, for example, without a knowledge of chemistry, you may be able to learn what happens, but you will not necessarily understand why. And if we look at the application of chemistry to medicine, even across the board, everything from salicylic acid inactivation of cyclooxygenase, all the way up to HIV-1 protease inhibition by ritonavir. You can see that small molecule chemistry is by and large the most important element of chemistry in the context of medicine. There are, of course, some exceptions, the exceptions being the biologics, such as the more recent ZMapp 3 monoclonal antibody treatment for Ebola. But equally, more reported within the last couple of years was the Niemann-Pick 1 inhibitor, which is actually a small molecule derivative. So chemistry itself is very important in the context of medicine. In these lectures, which forms part of the course as a whole, we will see how an atom is made up, how they come together, and how they interact with each other. As time has gone by, within the last 100 to 150 years, the scientific knowledge of mankind has increased, and matter has been found to be made up of smaller fundamental particles. In particular, if we look at subatomic particles, which you may be familiar with, such as protons, neutrons, and electrons, they themselves are actually made up of even smaller particles falling into the quark and lepton class. But as we will see, when we are discussing chemistry, we are principally looking at the movements and the interactions of electrons. Anything which indeed goes beneath that, in terms of size, typically speaking, we leave in the realms of physics. Chemistry is about the movement of electrons. Nuclear physics is about how nuclear particles interact with each other. And therefore, a knowledge of the latest developments in the discovery of these fundamental particles isn't necessarily essential for an appreciation of how electrons move around and how ionic, covalent molecules and formula units can be formed, respectively. As indicated in the previous slide, there are certain small fundamental particles, such as leptons and quarks, which are really unnecessary at this level for understanding about chemistry. Chemistry at its very heart, as I mentioned before, is about electrons and not necessarily about the nucleus. If you look at the board, you'll be able to see three fundamental particles that you are expected to be familiar with. They are the proton, the neutron, and the electron. The proton and the neutron are both nucleons. That is to say, they are subatomic particles which reside within the nucleus of an atom. Protons have a charge of +1, neutrons have a charge of 0. And they both have a mass of 1 atomic unit. 1 atomic unit, as you can see at the bottom of the board, is given as 1.67 times 10 to the minus 24 grams. And what is worthy of note, if you look at the table, is the third entry, the electron. Electrons have a charge of -1, but they have a substantially smaller mass. The mass of an electron is given relative to an AMU of 5.48 times 10 to the minus 4. However, the reality of this in kilograms is that an electron has a mass of 9.11 times 10 to the minus 31 kilograms. So very much smaller than those nucleons. Most of the atom is actually empty space, with the protons and the neutrons clustered together in the center. And this is something that was actually detected experimentally by Thomson and Rutherford. The electrons seemingly form a cloud around the central nucleus. And it is these electrons which engage with each other to form matter as we currently understand it, whether it's ionic or whether it is indeed covalent. And what we're going to be going through is how these individual arrangements of electrons, protons, and neutrons come to form the elements that we see within the periodic table, a very important index for the elements that we find on this planet.
You just completed your first video of the world's best medical exam preparation. Lecturio brings the knowledge of worldwide leading medical experts and teaching award winners to your PC, tablet, or smartphone. Prepare yourself and check your progress with thousands of quiz questions customized to USMLE standards. And the very best, you can get in touch with our medical experts personally. Visit Lecturio.com now and continue with the most inspiring medical education around the globe, anytime, anywhere.